function notation is another very important topic that we want to talk about. If you can simply think of function notation as a label that you're giving to some function. Why would we need to do that? One example might be in the business world. You can imagine having to work with it's like if you've got to work with an equation for, let's say, to represent your profit, and you've got an equation to represent your revenue, and you've got an equation to represent your cost. You need labels to keep all of that straight. So you'll see different letters being used to label functions. They can be really with any letter. Here we've got function, we just called it function H. This is going to be this list of ordered pairs here. And then this one, we've got the letter F. When you see F with parentheses together like this for your label, we read this as f of x. So that means the function f evaluated at x. Try not to let that confuse you if you've not seen it before. You can simply think of this entire f of x as just another way of writing your y. It's the same thing as your y. So we've got h equals this function with a list of ordered pairs, 1, 4, 6, 0, 7, 9. And then we've got the function f of x equals the square root of x minus 3. We are asked to find the following. Okay, so each of these pieces that we're being asked to do is a computation where we're being asked to evaluate our function at some specific value of x. In part A, we're asked to evaluate function h when x equals 7. So if you go to function h, can you tell me if x equals 7, what is y? Can you tell me what that is? If x equals 7, that puts me here, y equals 9. So that's my answer, 9. In part B, we are asked to find w if h of w equals 0. Well, what is this w? This is like the x value, and h of w is like the y value. So we need to go to the h function first, go here, all right? How did I know which was which? Well, because I know that if I've got h of w, this is always the y part. The inside of the parentheses is always like the x, which is the input. So going to the h function, I've got these ordered pairs where we've got w comma f, w comma f, w comma f. Oh, I'm sorry, not w. W comma h, I'm sorry. These are h. The h is like the y value. So I'm asked to find w if h of w is equal to 0. So I'm going to the h function. If h of w equals 0, that means y equals 0. Or you think of that as your second coordinate. So find the ordered pair where the second coordinate equals 0. And that would be this one. We're asked to give the w, which is the first coordinate in that situation. So that would be like your x. So because your y value is 0, your x value is 6. So w equals 6. So it's a pretty, it's not anything fancy going on there. They've just used new labels for everything. And you've got to be able to associate, you've got to know which one is your x and which one is your y. All right. For part C, I'm asked to evaluate f of 7. So I need to find my f function, which will be here, f of x. And then if x equals 7, what is y? That's what this is asking me. If x equals 7, then I'm going to have the square root of 7 minus 3, or the square root of 4, and the square root of 4 would give me 2. So my answer is 2. Part D, I'm asked to find x if f of x equals 5. So find f of x. If f of x equals 5, then I need this piece to be 5, then I have to solve it equal to this. So I've got 5 equals the square root of x minus 3. And I have to solve this. So how would I do that? Let you think about it for a moment. Pause if you need to. Because this is a square root function and I need to get the x out of the square root function, you can accomplish that if you square both sides. If I square both sides, I'm going to have 5 squared equals, and when I square a square root, they always cancel each other out and just give me the inside. So I have 5 squared equals x minus 3. with me a second while I get my boards lined up. Okay, so back here we simply squared both sides, and we've got 25 equals x minus 3. Add 3 to both sides, so 28 equals x. Okay. Example 6, we're given that f of x equals x squared minus 2, g of x equals 2x minus 3. With that information, we're asked to find, in part A, f of a. Basically, with these function problems, whatever you see inside parentheses will go into the original problem in place of your x. So this is telling me to go to the f function here and just simply replace x with the a. So that would just give me a squared minus 2. If I could simplify that, I would, but here there are no like terms that I can combine, so that's all I can do to this one. In part B, I've got f of a plus 1. So I'm going to let you think about this for a second. You need to find the f function. You want to replace the original x with the a plus 1 and then simplify that. So go ahead and try that. Pause the video. Okay, so you're going to substitute a plus 1 here for your a. You need to use parentheses, a plus 1 quantity squared minus 2. Alright, this is a binomial, so you'll expand it out, a plus 1 times a plus 1 minus 2. We need to FOIL. This is going to give us a squared plus 2a plus 1 minus 2. Combining like terms, I've got a squared plus 2a minus 1. And that's as far as I need to take it. Part C, we have to find f of x plus h minus f of x. So let's start with f of x plus h. This is telling me to go to the f function, substitute x plus h in place of all the original x's. So it's going to be parentheses x plus h, quantity squared minus 2. This is a binomial. We have to expand it out and FOIL. So that'll give me x squared plus xh plus xh is, or I guess we would say hx. It doesn't really matter. But you've got x times h plus h times x is going to give you 2 times hx plus h times h is h squared minus 2. Do you think I can combine anything? Can I simplify that at all? I do not have any like terms, so that's as far as I can take this part. So this is just the first part. Now I need to subtract f of x from this. So we're going to do f of x plus h minus f of x equals, and I'm going to have what I just got is x squared plus 2hx plus h squared minus 2 minus f of x. And sometimes people get tangled up at this part, so make sure you're following everything that I've done. I started out simply by finding the f of x plus h. So that was the first step. Now I'm just substituting my result back into what I was given. So putting all this back in here, and then we're going to subtract this x plus h, this x squared minus 2. Because I'm subtracting 2 terms, guess what I need to use? I need parentheses. Okay, so if you need to pause the video, make sure you're following what I've done. Okay, so this is our f of x plus h that we got from the first part, minus the original f of x piece. Now we need to distribute the negative. We'll have minus x squared plus 2. Now hopefully we can simplify a little bit more. I know that I can eliminate the 2's, the negative 2 and the positive 2, they cancel each other out. And then we've also got the positive x squared and the negative x squared we can cancel out. So we are left with just 2hx plus h squared. So please don't write this one off as being too hard because it's important. It's building up to another concept that we'll be working with in a few minutes. The next we want to talk about average rate of change. This is very similar to when you were working with slope, when you were working with equations of lines in Algebra 1, Algebra 2. The only difference with average rate of change is that this does not necessarily have to only apply to a straight line. It can be extended to a curve as well. As far as finding average rate of change, we're getting ready to look at an example. As we're reading through it, we want to be thinking about how we can take the information that we've been given and set up a set of ordered pairs. Once we have a set of ordered pairs, then we can find change in y over change in x like you would have when you were finding slope. So let's read the problem together. We've got the population of California was 29.8 million in 1990 and 33.9 million in 2000. What was the average rate of change of the population over that time interval? So how can we write this information as two ordered pairs? You have years and you have population. Which one of those do you think would be like the x value? Or like the input. We can also think of this as the independent variable. The year will determine the population. So we want to let x represent the number of, we want to let x represent the year. So we'll let x equal the year. Y will be the population in millions. So read the problem again and try to set up two ordered pairs from the information given and based on what we've just discussed. So I will let you pause the video and think about that. Okay, so your two ordered pairs, you should have the year 1990 as an x. The population in that year is 29.8 million. So we defined y to be in millions, so we'll just use 29.8 for our y variable. Our second order pair is the year 2000 for the x, and the population in 2000 is 33.9 million. With these two ordered pairs, we need to find change in y over change in x. So we want to do delta y over delta x. This is exactly like the slope formula. You're going to subtract the y values. So I'm going to do 33.9 minus 29.8. Over 2000 minus 1990. I will let you calculate that, so pause the video again. If you've done your calculations correctly, you should have an average rate of change of 0.41 million people per year. Sorry, that's probably, I don't know if you can see that or not. That was 0.41 million people per year. So with the example that we just did using average rate of change, we were still working with a linear model. If we want to extend that to a curve, we're going to want to extend our concept of the average rate of change. If we're still thinking of this in terms of change in y over change in x. If we let h, we're just going to substitute our change in x with the letter h. So just making that substitution, and we're also going to want to leave the xy notation and go to the function notation. So if we replace the y's from basically our slope formula with function notation f of x, it brings us to these two ordered pairs. This is what's been graphed in your notes in the figure that I've drawn for you. It can also be found in the textbook. But essentially, we've got x and then our y becomes f of x for the first point, and then we've got x plus h for the x, for the second x coordinate, f of x plus h. So that's like the x value, that's like the y value. We're going to make this substitution into the average rate of change, and that's going to give us a new formula, essentially, called the difference quotient. The difference quotient is very important for pre-calculus concepts. So we're going to look at some examples of how the difference quotient works. So example 8 part A, we're asked to calculate the difference quotient for the function j of x equal 3x plus 2. So this is like our almost like a formula that you've got to follow. You're going to start by finding f of x plus h. Of course, in this example, your f is like, your j is like your f. So this is the j function. So we need to find j of x plus h, and then we can subtract j of x, and then we'll divide the whole thing by h. Again, remember h was just another way of expressing our change in x. But we'll divide everything by h and see what happens. So go ahead and let's do j of x plus h first. So you just need to go to your original function, substitute x with x plus h. That's going to give us 3 times x plus h plus 2, 3x plus 3h plus 2. Then the formula tells me to now subtract the original function from what I just got. So j of x plus h minus j of x will give me the part that I just found, 3x plus 3h plus 2 minus the original j function, which needs to go in parentheses, 3x plus 2. We can simplify this. Pause the video at this point, just make sure that or if you need to make sure you're following so far. That's the nice thing about the videos, is you can pause me and you can go back and listen to what I just said, rather than having to just listen to me keep right on going. So always pause the video and go back and listen again if you need to. So go ahead and distribute, combine like terms. 3x plus 3h plus 2 minus 3x minus 2. And you can simplify this as far as possible at this point. 3x and 3x, that's gone. The 2's cancel out. The only thing that's left is 3h. Are we finished? No. The difference quotient told us to find f of x plus h minus f of x. That's all we've done. We've just done the numerator so far. Now we need to divide what we just found by h. If you want to put it all on one big problem from the start, that's fine, but I mean that's a matter of choice. That's up to you. So now dividing this by h. So now we can say that we've got j of x plus h minus j of x all over h equals, this is the numerator, 3h, divide by h, the h's cancel, and all that work gives us 3. That's one thing that you might find frustrating about these problems, is you have to do all these steps and you turn out with a little answer sometimes of just a single number. Sometimes, not every time. Okay? Let's look at part B. Okay, for part B, same type of problem. We're going to find the difference quotient. At least this time our function is an f instead of a j. That's nice. We've got f of x equals x squared minus 2x. So let's find f of x plus h. That's going to be parentheses x plus h quantity squared minus 2 parentheses x plus h. I'm going to expand this out. X plus h times x plus h minus 2x minus 2h. I have to FOIL, so that's going to give me x squared plus xh plus hx is going to be 2hx plus h squared minus 2x minus 2h. Normally you're not going to be able to simplify anything after you do this part. So we've got the f of x plus h. It usually will give you a long list of terms that cannot be combined yet. Now we're going to subtract the original function from what we just found. So now f of x plus h minus f of x just did. Minus the original function, x squared minus 2x. Alright, so we've got x squared plus 2hx plus h squared minus 2x minus 2h minus x squared plus 2x. At this step, you'll probably be able to eliminate a little bit, or maybe cross out some like terms. What can I eliminate here? I can see I've got x squared minus x squared, so I can cancel that out. And you've also got negative 2x and a positive 2x, so they're gone. So I have 2hx plus h squared minus 2h. And then the only thing I have left to do at this point, do you know? Before I tell you, think about it if you need to for a second. I now need to divide what I just found by h, and I'll be finished. So the entire thing, f of x plus h minus f of x all over h equals what we just did, 2hx plus h squared minus 2h all over h. All right. At this point, you can usually cancel out quite a bit, so just be careful though. If you want to think of this as breaking up into 3 separate terms and dividing by h, you can do that. Or you can think of this as factoring in h out of the top. At either way you look at it, you've got, let's see, let's go ahead and factor the h out of the top. So that leaves, I can say h parentheses 2x plus h minus 2 over h. And once I factored my h out, that gives me 1. So I'm left with 2x plus h minus 2 for my answer. These problems are not difficult, but they are very long, and you've got a lot to keep up with, so you are going to need to make sure you find plenty of time to practice these. 2x plus h minus 2 is my answer on that one.